Hello, good evening, and welcome to today's session. Today we're going to talk about T-SQL, and we're just going to look at the background theory of it and then do a few practicals around the core of the language. Yeah, so this is me. I'm experienced with database administration, and I'm currently in the enterprise architecture team, but I still do a little bit of hands-on with SQL Server. I'm certified in SQL, ITIL, Cisco, and AWS. Some of them a long time ago, some of them more recently. I have training in quite a number of database technologies, and you can see some of my articles on MS SQL tips, SQL Server Central, and coding site. So let's look at the foundations of the language. A lot of the material you see here are from a very strong will I say mentor, remote mentor of mine called Itzik Ben-Gan. He wrote the book T-SQL Foundations. He's done a lot of work with Solid Q, and a lot of materials that are here I learned from him. All right, the structured query language used to be called SQL, and of course it's still pronounced that way. It was based on a lot of theoretical work around relational database management systems or relational theory done by Dr. Edgar F. Codd, and it is an English-like language. It's a declarative language. That means you tell the system what you want it to do. You do not tell the system how you want it to do it. Yes, so when you say select star from, you don't tell the database engine how exactly it's supposed to execute that query. You just tell it what to do. And SQL is based on a set theory. That means set theory and predicate logic. We'll take a quick look at those two mathematical concepts, mathematical areas shortly within this presentation. All right, some of the commands that are used in SQL. There are just a few a few commands that make up the whole SQL set. I think about 16 of them. And we start with a group called the data control language group, the data control language, or DCL. So the grant and revoke are basically data control. That means the grant allows access to a principal, to an identity, to a user, basically. So when we say principal in SQL Server, we're talking about a user, we're talking about a certificate, we're talking about a login, we're talking about any entity that you can use to identify yourself in the system, that any entity that can own objects, so to speak, that can be granted permission of objects, that can access objects within the SQL environment. So that's what a principal is basically. So you also have the revoke, which allows you to remove the privilege or permission from that identity or that principal. The next group we're going to talk about is the data definition language group. So what this group does basically is commands that have to do with making alterations or affecting objects within SQL Server, affecting objects within SQL Server. So you find commands like create to introduce a new object, alter to change something about the object, or drop to remove the object from the database. So you have those set, which is the data definition language. You also have the data manipulation language, is the one that most people are accustomed to. Some people do not agree that select is a DML. Well, I don't agree myself, but typically it comes in this group. So the select is probably the most popular. That is the command you use to retrieve records from a database table or from a database structure that stores records. Then you have the insert, which introduces new rows, the update changes existing values, the delete removes rows, truncate that empties the table, and merge that reconciles contents of two data sets. Some people also consider truncate a DDL because the truncate doesn't really generate transaction logs, and what it basically does is basically zeroes out a table without not necessarily eliminating rows, but just zeroes out the table. And some of the truncate implicitly has a commit statement within it, within the struct, within the command. So it doesn't require, for example, in terms of normal practice, when you do an insert or an update or a delete, at the end of that session, you do either an implicit commit or an explicit commit. But truncate itself as a command does have the commit as part of the structure or the design of that command. So these are the data manipulation language commands in T-SQL and T-SQL's Transact SQL. All right, let's look at a little bit of background of the theory. I said we'll come back to this later. So we mentioned that there are two mathematical theories that are associated with SQL as a language, or Transact SQL. The first is set theory, and a set is a collection of M into a whole distinct object of a collection called M with distinct objects called M's, if you like, which are elements of M. Basically that's how the guy called Joseph Dobbin and George Cantor defined it. So the whole is a single entity. The distinct elements are entities within that entity. So you treat that is, you see, someone like Itzik Ben-Gan emphasizes this a lot, because it has a lot to do with how you write your queries, because you need to write your queries with the understanding that you're not doing a procedural language, you are doing you're doing a language that treats everything as a set. All right, so a table. So a table actually represents a set in effect. A table is also called a relation, is composed of columns and rows. So a table is one of the fundamental units within a database that contains your data, and it represents a set. You have to see it as a set in order to write queries properly. Then we talk about predicate logic. That is basically you may want to think about it as Boolean algebra, really. So in predicate logic, there's something called, we call it three-valued predicate logic. So an assertion can be true, it can be false, it can also be unknown. So unknown does not mean zero, and typically we represent unknown in SQL with a null. That means it's empty, it's an empty set. So when we say it's empty, we don't know what it could be. For example, if we had a column that we're populating with phone numbers, okay, let's say we have a column we're populating with gender. So we have a male. It can either be a male or a female, but maybe if we leave an entry empty, what we are saying is that we do not know whether he's male or a female. So in predicate logic, there are typically three values. Some people have actually proposed four-valued predicate logic. That is where you break down the unknown to unknown but available, or unknown and not available. I mean, it's another level of it. All right. So what we call predicates or filters basically are used in where clauses. So we say that we basically are trying to define a part of the set with this filter that we call the predicate, which is that expression that says name equals to this, or department greater than this, or age less than 50, etc. So those are predicates, the expressions that can either be true, can either be or false, or unknown. All right, the relational model. This is the basis for classifying relational DBMSs as relational, and it does not refer to the relationship between objects in terms of foreign key relationships or primary key relationships. It basically refers to the fact that this relational model, the foundation of it is tables, which used to be called relations, actually. Right? So constraints in SQL, we will encounter things like primary keys used to guarantee integrity, foreign keys to guarantee referential integrity. For example, if we have a table called orders and another table called order details, I mean, for there to be an entry in the order details table, there must have been an order. So you use a foreign key to maintain that referential integrity. We also have unique constraints, for example, where we are saying certain values within the table cannot be repeated. If, for example, you have a registration number, it makes sense for the integrity of your data that your registration number is not duplicated. You also have check constraints. For example, maybe you have a date entry, a date column. You want to check that values in that column are valid. For example, maybe you don't want to have any date any day in the month of February beyond 29. I mean, those are, you can put check constraints to determine that, to control those scenarios. Yeah, so normalization is also an interesting aspect of database management generally, or relational theory. Actually, it was also proposed or defined by Edgar F. Codd, and we typically talk about the third normal form in this guy Itzig Bengan said any normal human being should be limiting himself to the third normal form. So, but of course, I think there are 6 normal forms actually, and there are rules around these normal forms as stated in this slide, which basically try to ensure that your data is neatly arranged and organized among a set of tables such that you reduce the repetitions and you reduce the need to have to state particular values over and over again, and then you use relationships among those set of tables to make sure your data has some kind of integrity, right? So it's a whole big topic. There's a primer I wrote about it on coding site some time ago. All right, let's look at this aspect too, logical query processing. Here's where we start a little bit of sample, doing a little bit of demos or scripts. Here, if you look at this query is doing a fetch from the orders table, sales.order table. The sales in this case, which you see, let me just highlight that here, sales, this part of this, when you see the table name is written like this, sales.orders, is called the 2-part name. The first part in this case is the schema, the owner of the object, and the second part is the actual object itself, or the actual table. So then you have a where clause that really filters the data set that this select statement is going to pull out. And then you have a group by, which basically says after I get this data set as a complete set, I want to organize them in subsets, so to speak. And you determine what rules you use to organize the data set into subsets. And then when you look at a having statement or a having clause, what a having is to groups is what a where clause is to rows, basically. So when you say having, that means you are now looking at each of the groups that you have broken down using this group by clause, and you're saying you want only those groups that have more than one element in them, if you're thinking about them as a set, and then you do your order by. Now, in the execution of this query, even though it is written declaratively like this, it is written declaratively, you're just telling the database engine, do this for me. In executing this query, what your database engine will actually do is as follows. It will first of all say from, that means it wants to identify where am I getting all the data from. Then it will filter out what needs to be filtered out with a where clause. Then it will do the groupings of the resultant set and further filter out again the groups with a having clause. Then it will project them to you before ordering them, and you will see the implication of this order, of this processing order in certain practical terms when we write our queries. And you also see the reason for certain kinds of errors that you get when you try to write queries that you expect that an order is happening before a where, so to speak. So we'll see that in subsequent classes. All right. Okay, so let's do a little bit of practice here. Let me just pick out the some of the scripts that we're going to use to do that, and then I'll pull out my SQL Server Management Studio to see how we can demonstrate some of the things we have been talking about here. All right, so we're going to just create a sample database here, and that's what we're going to be using to do all the practices that we're going to do going forward. Yeah, so that's done. We call the database T-SQL v42. I mean, I did that because I already have an existing one. And the next thing we're going to do is we're going to create a few schemas. Then we're going to create a few tables. And we're going to stop there for now. And then in the next section, we will kind of like go ahead and do some more practice if at all we do get a good response. So we're going to just create a few of the schemas. Now let's examine the query here. What we're doing is basically we're checking if this database already exists. Drop it, because this is for the purpose of practice. That's why that is there. Then of course this error handling here for this drop statement, it can refuse, you can fail the drop for a number of reasons, so we have error handling there. And of course it's a simple statement that says create database and then the database name. Now when you do this, what happens is the database engine will create this database in the default path for we'll write the database files in the default path that is specified in the instance properties. Let me just show you that quickly. So if you see here where the database settings are, there's a default path stated here. So that means if you take the query, wherever you take it, it will work as long as you have once you've set up a SQL instance. So these directories define the default locations for databases, and so when you just use these 3 words or two clauses and one database name, you're able to get your database. And then we kind of like navigate into the context of our new database, and we're going to use that to create the 4 schemas that we need to continue our practice exercises. Okay, so we're also going to just create one table. I believe that's just one table, and of course it's just a sample. I'm going to also create the other tables because subsequently we're going to use them to do our exercises. We're also going to just create a table. We're creating this table in the HR schema. Notice what I mentioned earlier, where this is the schema and this is the table. This is a 2-part name. You can have 3-part names if you decide to specify the database itself, right? You can also have 4-part names where you decide to specify 01 the server. So this is equivalent. It still refers to the same table, and if we do that, it's just to prove that this is correct. You can do select star from. Yeah, but typically this is not necessary, except maybe you are referring to a table in a completely separate instance, where you want to get that separate instance using what you call a linked server with the same name as the instance where you have the table. So you have those happening. Now, so when you specify the table name, you have to indicate all the columns, you have to indicate their data types, and you have to indicate whether they are null or not, and so forth. And at the end of this statement, you have the constraint, a primary key constraint being created, being applied to the empid column on this table, as well as a foreign key related to the to itself, basically. So what it's doing is basically doing that because it's saying that the manager ID on this same table, so this is it's a foreign key reference in itself. The manager ID must exist as an employee ID before it can be inserted here. So that is a very important concept in this employees table. So we also have a check constraint where it's basically checking that the birth date is not greater than the current date and time. So that's what is happening here with this table creation. We can then do something extra here where we go ahead and add the indexes on this table. Yeah, just create a non-clustered index with the index name on, and we specify the table as well as the column on which this index will sit. Of course, in subsequent lectures we will do a lot more around indexes and tables and so forth. We're going to use the same method and create a lot of other tables in this database. So let me just open up another section so we see this clearly. So we see the same structure of table creation. Yeah, I believe we're right. 1 minute, I just want to be sure we have created, yeah, we have created production as a schema, so they shouldn't be giving me an error. Good. So we can create all the other objects in our new database. You see, after we've created all these objects, they are basically empty. We now have to run the queries that there is statements that will populate these tables. There are so many of them, so I mean it's basically one-liner insert statements, all over the place. It's a whole lot, but I'm just going to run it in the background, and that will be the end of today's session. And in another session we shall go ahead and do much more with respect to T-SQL query. Right. Okay, let me just get that out. All right. Okay, I'll just run this. A whole lot. It's a whole lot of queries, but this is another interesting object, the functions. We will go into more detail in it in subsequent sections. We also have views being created here. We also have, I believe we have some procedures here and there too. Right. So let's just run this, and that will be a little bit of a lengthy query. Yeah, that's fine. And but it's done. So we now have our table. Recall that when I first queried this, it was empty, but because we've populated it now, we now have data in it because we did a lot of inserts. We now have data in the table. So in subsequent subsequent demonstrations, we shall be able to refer to it in our training. All right, so this is where we're going to stop today. In the next section, in the next lesson, we are going to do some exploring of these queries. And if you want to be part of that, I want you to just make a comment in the video and let me know whether this is actually useful to you. I know that databases and SQL are being a little dated, so if you feel this is still useful to you, I want you to make a comment in the video and let me know that I should continue with the series in this that this covers T-SQL as a language. Thank you for your time and have a great